In this video, I want to give a general idea of hypothesis testing. In a lot of situations, investigators have to decide whether some statement regarding a parameter is true. As an example, if we have a new drug that says it's supposed to lower blood pressure, we need to make sure that the actual mean blood pressure is lower. In this case, the hypothesis is a statement regarding the value of a parameter of interest. We do have a parameter that we're interested in my example, blood pressure, and then the statement regarding that it is lowered. And so we want to look at testing that hypothesis, deciding whether a certain hypothesis is true for a given parameter. So, deciding, does this new drug actually lower blood pressure? An easy way to test this would be to take the value of my sample that has had this drug in my drug trial and find a confidence interval around that to see if that mean value is actually lower than the true population mean. And there is a close connection between confidence intervals and hypothesis testing, but there's a lot of very specific issues that arise in hypothesis testing. So it's not ideal to just use a confidence interval. Instead, we want to look at how to actually perform a hypothesis test to avoid these strange cases. There are two ways to do a hypothesis test. The first is the standard method. And so I'm going to walk through the steps and kind of explain the general idea of what it is that we're doing. The first step is to state your hypotheses. We actually have two different hypotheses in a hypothesis test, and we will actually address those in a later video on how to find them and state them appropriately. We're then going to determine a test value. And the way we determine this is going to depend on what type of test it is that we need to run. We then need to determine what's known as a critical value. And so we'll look at how to properly find both the test value and the critical value in a separate video. The next thing is to determine your critical value, which is going to essentially be a cutoff value. And then finally, we need to actually make a decision. So let's look at exactly what it is that we're doing here. We will be using a normal or a t-distribution. So the idea is we are going to set up this interval. In this case, this value here, I'm going to call mu0. This is the actual hypothesis mean. What we are hypothesizing is the mean. My test value, this is determined by the sample. And so we'll look at how to find it. But let's say this right here is my test value. So I'm going to put a T on it for test. The critical value is essentially our cutoff point. What is actually considered too low? And this depends on our level of significance, our alpha value. So we will have a cutoff value in general. And so let's say my critical value is here along this bar. I'll use C for critical. And then we need to make a decision depending on where C and T are in relation to each other, which one is closer to the population mean, which one is further out along the tail. And this is the idea of the standard method. We're going to find the mean, we're going to find our test value, we're going to find our cutoff point, and we're going to have to make a decision depending. And in later videos, I will slowly address each one of these bullet points and each one of these steps in this method a lot more closely. The second method is known as the p-value method. The first step to the p-value method is to still state your hypotheses. We're then going to determine our test value just like we did before. We're then going to find what's known as the p-value. And then we'll make a decision. So let's look at what exactly it is that we're doing in this method. Once again, I'm going to use my normal distribution and t-distribution. I'm going to put my hypothesized mean in the center. I'm going to determine my test value just like before. I'll mark this as t. This comes from my sample. And then the p-value is actually a probability. It actually tells the probability of this region right here. We're actually trying to figure out the probability of this region here. The idea being, what is the chance that we got a random sample that was this far out along the tail or further? So essentially we're looking at the probability that my value is less than or equal to my test value. And then we'll make a decision based on that. The idea being, if this probability is too low and this thing is too far along the tail, then it is very unlikely that it happened by chance. And so in future videos, we'll go through both of these methods and each one of these bullet points slowly.